In this recording, I'm going to be running through a first introduction to writing a new connector for Kafka Connect. So this is Kafka. Now we often think of Kafka as meaning the brokers that make up a Kafka cluster, but the Apache Kafka project includes an ecosystem of pieces that enable your whole event-driven architecture. Today we're going to be talking about Kafka Connect, the framework that enables getting data into Kafka topics from external systems and for sending data from Kafka topics to external systems. A Connect pipeline is made up of multiple components. Starting with a source pipeline, what you do is you're assembling a pipeline of a connector that gets the data from the external system, transformations that modify and filter the data from the connector, and a converter that converts it into the right output format, such as JSON, Avro, or XML. For a sync pipeline, it's the same sequence of components, but in reverse. You assemble a pipeline of a converter, something that reads the data from the Kafka topic, and again, that could be like JSON, Avro, XML, and so on, that parses it into a structured record. Transformations that can take those structured records and modify them and filter them, and a connector that submits those transformed records to some external systems. Kafka Connect comes with a wide variety of existing transformation plugins covering the most common sorts of modifications you'll need to make. And there's a wide variety of converters out there that cover the most common data formats. Today, we're going to be looking at connector plugins, how to create a new connector plugin to do the job of getting data from an external system and putting it into the Connect pipeline, and how to create a new connector plugin to do the job of submitting Connect pipeline records to an external system. I've created a simple project that will illustrate how connectors are created. Let's start by setting this up. The first thing that you're going to need to do is to clone this repo. So I'm going to click on code, grab the URL and switch to my terminal. Git clone that address. And then I'll cd into it. Actually, I'm going to grab where I've cloned it because I'm going to use that in a minute in these other terminals. Most of what you're going to need to do is included in the README here. So I'm just going to sort of show you me walking through these steps. So the first thing to do is to check that you've got the prereqs you're going to need for this project, which is basically Java and Maven. If you've got that, you're good to proceed. Next thing to do is to download Kafka. This is going to download the latest version of Kafka and unzip it for you. Now, if you've already got Kafka on your system, that's fine. You can use that. The later scripts have a Kafka home environment variable, and you can point that at your existing setup. This is just assuming you're starting from absolute scratch and to give you everything you need to get started. While that's downloading, the next thing we're going to do is start Kafka running, which is this script here. So this will run Zookeeper and Kafka, point them at each other and get it all started and ready for you to use. To give it a try, the easiest thing to do is to start with one of the pre-existing connectors. So to do that, we're going to start with one of the simplest connectors out there, which is the file stream connector. It's a source connector that is going to tail a file, and every new line that gets written to that file, it's going to send to a Kafka topic. So we'll start by consuming from the topic, start listening to the topic where it's going to send the contents of the file. You will see warnings because the topic doesn't exist. That's totally fine. It's okay to ignore them. And actually, before I do the next bit, so this is the file we're going to be doing. It's got one line of lorem ipsum in there, so we'll see that show up as a message on the Kafka topic. I just need to update the config file, the properties file. I'm going to grab the location of the file to make this sort of a full absolute location of the file. And I'll save that. So now I can run the connector with that script there. So this is starting the connector, and you can see here where we're listening to the topic, that lorem ipsum file was written to the Kafka topic, and we can do a few more. So if I echo hello to that file, you'll see that show up on the Kafka topic there. And I'll do one more. I added a couple of lines to the file and they showed up on the Kafka topic. So that's kind of an example of the simplest connector you can run that's getting data from some external system, in this case my file system, and then bringing it into my Kafka topic. So I can close that. I'll stop that connector and I'll stop listening to that topic. So now you've got a working development environment, let's look at how to create a new connector. I'm going to start by walking through some key bits of the code, and then I'm going to give you a quick demo going back to that repo we were just using. I'll run through how you build and run a new connector. I'm going to start with creating a sync connector because they're often a bit simpler. At a high level, this is what we want to achieve. We want to get data from a Kafka topic and send it to an external system. Now, the key thing to recognize is our connector doesn't have to do all of this work. Kafka Connect is going to get the events from the topic for us. It's going to give the events to our connector by calling a put method that we're going to write in our connector class. Creating a sync connector means you create a Java class that implements a put method, and then once you've configured it, your connector just needs to wait for the Kafka Connect framework to call your method with those events that it should then send to some external system. At a very simple level, this is what we're going to be doing to create a sync connector. But let's dig into the code a little bit deeper. I wanted the skeleton project in this repo to be a real connector that you can compile and run. So I needed a real external system. So for this project, I've gone with Slack. Running this connector is going to get messages from a Kafka topic and then send them as messages in a Slack channel. Now, when we talk about a connector, there are a few pieces involved. These are the files we're going to be going through. Logically, though, you can think of it a bit like this. There's something that defines the config options that your connector is going to have. So for this connector, we need two config options. We need an API token so we can authenticate with the Slack API, and we need the ID of the channel that we're going to send messages to. Notice from this code that Kafka Connect gives us a bunch of classes to help us define config options. We can specify the type of the option. So, some of your config options might be numbers, some might be strings, and so on. You can specify some validation rules. So for a numeric config option, you can specify a valid range. For a string config option, you can specify patterns or the required length, and so on. Next, the connector class. This essentially has the job of defining your connector. It's the top level piece that is going to orchestrate or coordinate the work that your connector needs to do. So most of this can just be boilerplate stuff. What you're doing, and if you sort of see here on line 34, you're extending the sync connector class, and then you have to implement a few of the methods. Now, most of this is just pointing at those other pieces in my diagram. It's pointing at the config options on line 50, and it's pointing at the task class on line 56, and we're going to be looking at the task next. The connector is responsible for defining the config for each of the tasks, and like I say, we are going to dig into what a task is in just a moment. Now, this is useful where you want to run multiple tasks and give each task a slightly different job to do. So this task configs method on line 68, that's where you can use the config that's been given to the overall connector and use it to generate a config for each individual task. And like I say, we should talk about what tasks are. Now, a task is the class that's actually going to do the work. Now, when you configure your Kafka Connect pipeline to run one of these things, you get to specify how many tasks you want to run. Kafka Connect will then spin up that many instances of your sync task class in parallel, and it will handle giving separate events to each one. So for our Slack example project, you could, for example, have 4 tasks running, and each of these will be putting separate Kafka events to that same Slack channel. So this is what the task looks like. Again, it's extending a Kafka Connect class, in this case, sync task. If you look at the start method, this is where you're doing your setup work. You're given the config options, those options that have just been prepared by the connector class, and then you use those to do whatever setup you need. So for this connector that's going to be sending messages into Slack, it needs to get the channel ID and the Slack token out of the config it's been given, and it's going to use that to prepare a Slack client using Slack's Java SDK. Now, when you're writing your connector, you're going to be replacing this with whatever client is appropriate for the external system you're going to be using. The important bit is the put method that I had on my slides before. This is the method that Kafka Connect is going to call with the records, with the events, the messages that it got from the Kafka topic, the records that it wants your connector to send to some external system. So if you look on line 72, I'm calling the chat post message method. So with each Kafka message that Kafka Connect has given me, I'm sending it as a separate message into Slack. Now for your connector, you're going to be replacing this with whatever code is appropriate for sending data to your external system. Notice underneath that in the sort of lines 80 and below, if you fail to send the messages to the external system, you can let Kafka Connect know this by throwing an exception. And what you can see here is that if you throw a retriable exception, Kafka Connect will give your connector the records again in a later put call. So that means you get to try again. But if you throw any other exception, Kafka Connect will stop the task and put it into an error state. And that means the administrator, your user, can then investigate the problem and see what's wrong. The stop method is where you get to do any cleanup or teardown that your connector task needs. This is going to be called by Kafka Connect when the connector is stopping. Now, I haven't got any explicit disconnect method in Slack's client SDK, so there wasn't much for me to do here except let the Slack client instance be garbage collected. For your connector, you might want to close some connections or do some other cleanup, depending on what external system you're interacting with. So that is what all logically goes into that My Connector box here. There's a config class that defines the options you need, a sync task class that actually does the work of sending messages, in this case to Slack, and then a sync connector class that points at both of them. So let's see that in action. So back to that repo that we had earlier. It's still running Kafka in this window from before. And I'm still going to be going through the commands in this README. So the first thing to do is to compile things. Actually, what I'll do is I'll show you. So the code that we were just going through lives here. So these are the three files that we've just been talking about. So the first thing we need to do is to compile this. And there's a script for that, which is this build connectors one here. So I'm going to copy that and run it here. Okay. So the next thing to do, we need to edit the properties file with those two config options we were talking about, the token and the ID of where to send messages to. So I'm going to switch to here and edit that sync connect properties. So I need the Slack token and the channel ID. So I'm going to start with the channel. So this is the Slack channel I'm going to use. You can see I use it for all sorts of demo things occasionally. I just need this ID from the bottom here. I'm going to copy that and paste that in here so my connector knows where to send the messages to. And then I need a token for this. So that's everything I need. Only thing left to do is to start it running. I'm going to copy that and paste that in there. So this is going to start consuming from the Slack demo topic, and any messages that are received on that Kafka topic will be sent to this Slack channel. There's a script to help you send messages to that Kafka topic, so you can try this out. So if I paste that in here, I can start sending my messages to the topic. So I'll imaginatively, again, use hello world, send that message, and you can see this shows up in my Slack channel. This is a message coming from Kafka. And there it is. So hopefully what you can see there is all the code we just talked through. You can try it out for yourself. You'll just need to get your own Slack token first. But otherwise, the idea of this sample project is to give you everything you need to actually see a running, working connector. Next, we're going to take a look at how to create a source connector. Now this needs to go in the other direction. We're getting data from an external system and we're sending it into a Kafka topic. So this is the objective. We want to get data from an external system and send it to Kafka. But again, a source connector isn't going to do all of this. A source connector isn't sending messages to Kafka. because there's no point every one of the hundreds of source connectors out there all having had to re-implement how do you reliably deliver messages into Kafka, because of course all source connectors would have otherwise needed to do that. Instead, Kafka Connect handles getting the events into the Kafka topics, and it gets the events that it delivers to the Kafka topics from our connectors. It does that by calling a poll method. So that means my connector doesn't have to worry about the details of talking to Kafka. I just have to implement a poll method, and then Kafka Connect will call it when it's ready. Now, when that poll method is called, my connector can go and get the latest data from the external system. Now, in the template project we're going to go through, I'm using REST API calls to do this, but connectors can use any type of technology, any type of technique that's appropriate for the external system we're interested in. It's going to be getting events by making some REST calls, some HTTP calls. And in this case, for my connector, it's going to bring back some JSON. And it's going to need to parse those JSON responses into Java objects. It's going to return those objects to Kafka Connect in the shape that Connect expects. And we'll talk more about that in a moment. And then it's done. The connector doesn't need to worry about anything else. Kafka Connect is going to handle reliably getting those events to the appropriate Kafka topics. And in a moment, we're going to talk about how does Connect know which topics to send events to. But this is the flow. Connect calls the connector's poll method. The connector has to go and get some events and then return them. Now I'm going to squash that bit up because once Kafka Connect has delivered the events to the topics, it's going to come back to the connector and ask for more. It's going to call that poll method again. My connector can then go back to the external system, get any new updates, get some new events, and then return them to Kafka Connect. And this sort of process repeats forever. For the template connector project, I'm using Weather API. They offer a free API for getting weather data, so it's good for this kind of first demo project. So going back to the template project for the source connector, this one is a bit more complex. I'm going to get to the reasons why it is in just a moment. Let's start with the easy bits that are pretty similar to the sync task. First, the config class. Like before, you specify the options that your connector is going to need to be configured. Are some of your options optional or required? Are there default values that you want to use if a config option isn't provided? Are there validation rules that you want to apply to recognize a valid config option value? As a developer of a new connector, you don't need to implement how to process options yourself. This config def class that you can see I'm creating on line 34 does a lot of the work for you. It lets you define the rules, and then Kafka Connect will handle enforcing it for you. So if a user doesn't provide the right config, if they provide a string when you wanted a number, or if they provide a number that's not in the range your connector needs, it will handle rejecting that for you and giving the right error message to the user. So you can be sure the options that your connector is going to be given are going to be what you expect. Next up, the connector class. As with the sync connector, most of this is often going to be boilerplate stuff. You're extending the source connector class this time, and again, implementing a few of the methods. Now, most of this, like before, just needs to point at the other pieces. It needs to point at the config options, and it needs to point at the task class, and we're going to look at the task next. As before, the connector is responsible for defining the config for each of the tasks. Now, I talked before that when someone is running a connector, they might want to run multiple tasks. And I showed you how the connector is setting up the config for each of those tasks. Now, in this example, what I'm showing is another option you've got when writing a connector on line 69 here. And you could do this with sync connectors as well. And what I'm doing here is I'm ignoring what the user asked for. I'm just setting the config up for a single task instance, regardless of how many tasks they wanted. If your connector is connecting to an external system where it doesn't make sense to have multiple connections in parallel, you might want to do this. Now, remember what I was saying. At a high level, the idea is that Connect calls your connector goes to get data from an external system and then returns it. The connector then sends that to Kafka, and once it's finished, it comes back and calls your connector again to repeat the process. Now, that's often a bit of an oversimplification. If my connector actually did this, I would burn through the limit for my weather API key very, very quickly. Now, I've only created a free plan API key with the weather API service, and that has a strict limit on how many times I can call the API. Each of these gold arrows here on my slide would be using up my API calls allowance. So I needed to make the connector very slightly more complicated. My connector sets up a queue when it starts up, an in-memory queue, a Java queue. And then in a background thread, it's periodically polling the weather API to get the latest weather update. Anytime there's a new weather update, it puts it on that queue. And that's all this thread is doing. Periodically polling that API, checking for a new weather event, and then adding them to this in-memory queue. And then when Connect calls my connector with that poll method, it can take whatever updates are currently waiting on the queue and then immediately return them. The nice thing about decoupling it in this way is it means that Connect doesn't get to decide how often I make API calls to the weather API service. Connect can call my connector's poll method as frequently as it likes, and it will call it repeatedly again. As soon as it's finished sending the last lot of messages, it's going to come back to the connector and ask for some more. By decoupling these two threads, it means I stay in control of how often the connector is calling the weather API, and I can tune this thread that's doing the fetching, the polling of events, so that it polls as frequently as is allowed by whatever plan I've signed up for with this API service. So that's why you might have noticed in the config options, that bottom config option, I put a poll interval in there. So that means someone who's running this connector gets to choose how frequently they want the connector to call the API. Now, it's not just about API key limits. There are other good reasons why you might want to decouple your poll implementation from actually getting the data from the backend system. And it's not just about sort of financial or API key limits. Often there are good performance reasons to do it this way. Whatever your backend external system is, if it doesn't have a blocking get method, and if you don't want Connect to hammer it into the ground with a very fast set of repeated poll messages, this is a simple way you can keep in control. So this kind of pattern is really common. So let's take a look at the task class to see how this sort of separate thread can be done. So this is the start method for my task, and I'm creating what I've called a data fetcher class. That data fetcher is going to be the thing that sets up the queue. And you can see on line 70, I'm using just standard Java timer class to drive this. It's going to periodically poll to put things onto the queue. So let's have a look at that data fetcher class. It's subclassing the standard Java timer task. So that means it's a class with a run method, and the Java timer is going to call that run method on that poll fixed interval schedule. You can see it doesn't actually have very much to do. It makes the API call to the weather API REST API. It does that gets back some JSON, and then it parses the JSON into Java objects. And then the objects that it gets, it's putting them on a queue. Now for this sample project, I've used a tree set. You can see I create that in the constructor on line 72. I chose a tree set because it lets me specify an order. The comparator I'm giving it means I'm sorting the events based on the timestamp in the response. And also because it's a set, it helps me to avoid adding duplicate events. So that's the left side of the connector. I set up a normal Java timer, and then I give that a timer task that is going to be responsible for polling the API and adding the weather events it gets to a local in-memory queue. Let's look again at the right-hand side. What happens when the Kafka Connect framework calls my task with that poll method? So you can see that here on line 90. It's just getting the records that are currently available from my data fetcher class. So that's getting those events from the queue. It's turning those JSON API response objects into source records, which it then returns in a list. Leaving the queues and threads and all of that stuff to one side for the moment, I should explain what I mean by a source record. The connector is returning a list of source record objects because that's what Connect expects. So what do you find in each of these things? Well, firstly, it says which Kafka topic and partition this message is meant for. Each source record needs to tell Kafka Connect where it should produce that message to. And that's what I'm doing here. I'm calling a method that's got to work out the right topic name for this event. Now, for this, I've just got a hard-coded string that you can see down on line 111. So for this sample project, my connector is going to send all of the events to the same topic, a topic called weather demo. But your method might be a bit more complicated. You could set this value based on a config option if you want to allow your users to specify the destination topic. That's a really common thing for connectors to do. Or you could set this value based on something in that API response. So, for example, if you wanted to send rain and storm events to one topic and then clear weather events to a different topic, then you could use the weather event data and dynamically set the topic name accordingly. That's also a pretty common approach. What else goes into that source record? Well, obviously the message itself, something that Connect can serialize using whatever converter it's been configured to use. The idea is that the message is just something that Connect is going to be able to produce to the topic. There's also some other things you put in there, including the offset. Now, the offset, and this often gets mixed up, don't think of this as in a consumer offset that you might be used to. This is a bit different. An offset in a source record is a description of when in the history, in the timeline of whatever your external backend data source is, how do you describe where this event should fit? Where is it in that timeline? And this is really dependent on the data you're getting from the external system. As a developer of a new connector, it's on you to choose the right value to use because it is very dependent on your data source. If your backend external data system is something like a database, you might use something like a row ID for this. Now, for me, the API responses I get back from the weather API all have a timestamp in them. So that timestamp makes for a really good offset. And you can see that I'm using that here in line 94, that's getting it from on line 107, a get epoch timestamp. So when I create my source record, as well as saying, here's the message, here's the topic I want it to go to, I'm also saying, here is when the event is logically from. Now, why do we tell this to Connect? It's because Kafka Connect is going to remember that. Now, when it's running in distributed mode, it's going to store that safely away onto an offsets topic. And again, like I said, this isn't the consumer offsets topic. This is just a different thing that's also got offset in the name. This is an offsets topic that's dedicated for use by this Kafka Connect instance. If you're running in standalone mode, it's going to put it in a file somewhere. But either way, the idea is that Kafka Connect is going to remember the latest message that it's handled for all of the connectors that it's running. And it does that so that at startup time, it can go back and retrieve those offsets and give them to the connector. So what it's doing is it's saying the last time you were running, the last weather event you gave me was from this time. Now, if it didn't do that, think what would happen every time the connector needed to restart. I make an API call to the weather API. That gets the most recent weather event, and that gets delivered to Kafka. Then imagine Connect has to restart. My connector would then make immediately another API call to the weather API. It gets the same weather update, and then that would get delivered to Kafka. It would be an event that I'd already produced to the topic before Connect had restarted. I would have produced a duplicate message. And for connectors that are getting batches of things, like whole sets of updates from some external system, it would mean you could potentially produce many, many duplicates onto the Kafka topic. So instead, the point of including an offset in every source record you return to Connect is so that Connect can keep that safe for you. And at startup, it means Connect can tell you what you've already sent, what was the most recent thing you've already sent. And it does that to help you avoid duplicates. So here's how my task is doing that. At startup, it gets the helper class that lets me read the state from the offsets topic, what's called an offset storage reader. I use that offset storage reader to look up the most recent offset timestamp for each of the topics that my connector is returning source records for. Now remember, this didn't have to be a timestamp. It could have been a row ID, could have been something more complex. Now, I know that I'm putting timestamp epoch numbers, longs, in all of my source records. So I know that I can cast what I get back off the offsets topic into a long. You will need to decide what's a sensible thing for you to put in your offset, in your source records. And then when you're reading that back from the offsets topic, you'll need to convert it accordingly. But now that I've got that long, what was the offset for the last thing that I gave Connect? My connector can use that to know when to ignore, when to filter out what it gets back from the weather API. Anytime I get something back that has a timestamp that isn't after the timestamp connector's told it has already been sent to Kafka, I know it's safe to drop that. This means that I'm only adding something to my in-memory queue if it's newer than the events that Connect has told us we've previously delivered. There are other interesting bits you can include in the source record that I haven't really got time to get into now, headers, keys, and so on, but this is enough to give you an idea. So let's switch to a demo again and see it in action. So back to our sample repo. This time we're using these source classes that we've just been talking about here. I just need to stop that last connector, the sync connector, and the consumer we ran before, and I'm just going to clear my terminals. So again, the commands we need are all here in the source section. If you didn't build the connectors in the previous step, you can run that now. It's just going to do a compile of these Java classes. Like before, we do need to edit the properties file. So we need to go to this source connector properties, and there's a couple of values that are missing. The API key that it's going to use to fetch the weather reports, and the location of where you want to get the weather updates for. So I'm going to put in Hersley, the postcode for Hersley, and for my API key, I'll paste that in there. So if I clear that, I'm going to start a Kafka consumer on my weather topic so that I can see the events that come through. And again, like before, you will see a warning because that topic didn't exist before, but that's totally fine to ignore. And then the last thing to do is to run the connector. And you can see the first weather event has come through. And only when this changes will I see a new event come through. And if I Control-C to kill that and then run it again, because we're storing that offset, as I described, we don't see a duplicate message. So it's safe to restart this over and over again, and it's not going to result in duplicate messages being produced to the Kafka topic every time. So that is your introduction to being a developer with Kafka Connect. Hopefully what I've shown you is that it's easy to start creating new connectors. Kafka Connect is doing most of the Kafka specific work for you. You just need to think about the best way to interact with some useful external system and implement the right Java methods that Connect is expecting. Thanks very much for listening.